Okay, so now we're going to go over acid-base reactions. We went over precipitation reaction, and that's when two reactants come together to form a solid. Now let's look at acid-base reactions. An acid-base reaction is when an acid and base, hence an acid-base reaction, react together to neutralize each other. And an acid is the substance, we looked at acid naming in chapter 3, that has an H in front of it. Okay, examples of acid would be your stomach acid, which is hydrochloric acid, vinegar, which is acetic acid, aspirin, which is salicylic acid, vitamin C, and soft drinks like phosphoric acid. And a base typically will produce a hydroxide ion OH in an aqueous solution. So an example of this would be plaster of Paris, Alka-Seltzer, Drano, ammonia. So Alka-Seltzer, you take it because your stomach is upset. Your stomach is upset because it's too acidic. There's too much acid in your stomach. So remember, what does an acid-base reaction do? They neutralize each other. So you take this Alka-Seltzer, okay, and you react it with the acid in your stomach, hydrochloric acid, and they will neutralize each other. So let's look what happens when an acid-base reaction neutralizes each other. Okay, your acid, we're going to say that's H plus because it has to have a hydrogen in it, and your base, we'll say it's OH because it has to have an OH ion, according to these rules we're looking at right now. So when H and OH react together, what do we get? Water. So that's what happens. When an acid-base react together, they all end up have water as their net ionic equation. So let's look at let me show you. Let's look at a molecular and ionic equation between HI and BaOH. Okay, and let's see what this forms. Let's look at the net ionic. So the acid-base, because I have HI, that's what I'm really going to look for is a acid. This is my acid right here because I have a hydrogen in front. Plus BaOH2. This is my base because I have an OH. So anytime I see an H at the beginning of something and an OH in there, that's my acid and base. Okay? And let's see what these form. Okay? I have so I'm going to switch partners. So this is going to form water, H and OH. You see, this is our liquid. Oops. Liquid water plus BaI. And let's make sure these are balanced, okay? We have OH2 and H. So H2O, we have 2 of those, 4 of those, so there's going to be 2 waters here. So I have 4, so I'm going to have 2 of these, balancing this equation. Okay, and then barium, so OH has a -1 charge, the polyatomic ion. Okay, but I have 2 of those, so barium has a +2 charge. Also, barium is in group 2. Let me show you again. We're looking at, there it is. Barium, group 2, so it has a +2 charge. Okay, and iodine is in group 7, so it has a -1, and hydrogen has a +1 charge. Okay? So when I look at these together, barium here, again, will have a +2. This is a -1. Those aren't neutral yet, so I need 2 iodines, okay, right, to neutralize the barium. Okay, so all I did here was just balance the equation. If you don't remember how to do that, go back to, I believe it's chapter 3. So all I did was balance the equation here. Okay, now let's look at the, I told you for an acid-base reaction, the net ionic should should create water. Okay, these are all going to be aqueous. Oh. Water is considered a liquid. It's not considered aqueous. It's a strange thing that anytime you see water in a product, it's considered a liquid and not aqueous. So it's kind of like insoluble, sort of, if you want. Okay, so let's break it up into its ionic equation. So we're going to have 2 H pluses, right? Because we have 2 of them with a +1 charge, plus iodine. How many? 2 iodine. All right. Barium, we only have 1 barium, but it has a 2+ charge. Hydroxide, we have 2 hydroxides with a -1 charge, because the 2 right here, we have 2 hydroxides. Water is going to stay as water, so 2 H2O plus 1 barium with a 2+ charge plus 2 iodines with a -1 charge. Again, 2 because it says there's 2 of them, so I say that there are 2 of them with a -1 charge. Now let's cancel everything out. Let me change my color here. So iodine, there are 2 iodines with a -1 charge right here and over here. Barium 2+ and barium 2+, and that's it. So this, and this remain. Okay, so I have 2H plus 2OH minus yields to 2 waters, because I have 2 right here. Okay, but if I minimize all this, so 2 cancels out 2, cancels out 2. Okay, so basically H plus OH minus makes water. So that's how you always know it's an acid-base reaction. The net ionic will always be H plus OH minus is water. Okay, you can recognize these because you're going to have an acid which starts with a hydrogen and a base which will have hydroxide in it. Okay, so that is your acid-base reaction. They always will react together to create neutral water.